I'm sure you remember Oumuamua, the first interstellar object discovered in the solar system with such a bizarre shape and behavior that even science couldn't rule out the possibility that it was alien technology. But just 2 years later, Dosi Borisov, the second interstellar object, was discovered. And just a few weeks ago, boom, 3 and Atlas. Indeed, the third of its kind, about which the controversial physicist Avi Aviloev has suggested the possibility that it could be hostile alien technology. It's getting closer and will be at its closest point to Earth on December 19th of this year. These objects are messengers from other planetary systems, from stars and worlds that humans will never be able to reach. The speed of light limit has us completely isolated from the rest of the universe, with these fragments being the only direct information we can get. Hello and welcome to Chide Ciencia. They don't seem so unreachable, do they? You can look at the sky and see those stars, and there are even telescopes that can see the planets orbiting them. And in some extraordinary cases, we can even estimate the chemical composition of their atmospheres. But this would be like saying you know someone just by looking at a picture of them. These objects are not just a handful of photons wrung for every bit of relevant information. No. They are literally pieces of those systems, of those worlds, possibly full of unknown minerals, exotic chemicals, mysterious magnetic patterns. And even probably some of them contain life, interstellar life. And this could change our existence forever. Before 1928, people died from a simple infection, but Mr. Fleming dedicated himself to studying a field of knowledge, which until then was almost as unknown as extraterrestrial life is today. And what he found, penicillin, changed the course of humanity forever, saving hundreds of millions of people. If this revolution was possible by studying a terrestrial enigma, just imagine the enormous potential these galactic capsules could hold. New, revolutionary chemical substances, materials that would seem to defy the laws of physics, biochemical processes comparable to black magic. Who knows, maybe these objects hold the key to developing nuclear fission reactors, space elevators, superconductors, or more effective medicines against aging or cancer. And this is just the quote-unquote useful part, because in science nothing is useless. If it seems that way, it just needs more time. Because besides all this, they would allow us to understand how extraordinary or common Earth is. Depending on the chemical behavior of these bodies, we might discover that systems like ours, with so much water, so many metals, or so much carbon, are actually very rare, an anomaly, or, on the contrary, the norm. Both answers would have tremendous implications for the probability of extraterrestrial life and for models of planetary system formation. It could confirm that it's likely we are surrounded by interstellar neighbors, or that Earth is an oasis of life surrounded by death and darkness. Both possibilities are equally terrifying. And since we're talking about life, we have to talk about intelligent life. I mean, we're talking about interstellar rocks that have been drifting around out there for who knows how long, traveling between systems, maybe carrying traces of all of them. We could find, for example, metal alloys that can't be formed under natural conditions, or a magnetic anomaly in their crystals with a non-random pattern, and even fossils, spores, life. Because do you know what one of the events most likely to generate interstellar fragments is? Well, a planetary scale collision. Some of these bodies could come from planets that were once full of life, which suffered a cataclysmic impact that scattered their fragments throughout the galaxy. If they're so important, why did we let Oumuamua and Borisov get away? And what will happen with Atlas? Well, the problem is the speed. Atlas, for example, at its closest point to the Sun, will have a speed of 68 kilometers per second. The International Space Station orbits the Earth at 8 kilometers per second. A probe that wanted to study these bodies would have to reach a tremendous speed in a very short time. That's why the orbital dynamics involved are extremely complicated. But the summary is that, to be able to reach these objects, we have 3 options. The first is the simplest, and, at the same time, the most expensive. Go directly to the object from Earth. For that, the largest rocket in history by far would have to be built. We're talking about a multi-stage rocket that's much bigger than the Saturn V or the Starship, which are already giants themselves. It would be a colossal undertaking that right now no public or private space agency can handle economically or logistically. The second option is to use the gravity of the planets in a fascinating maneuver called a gravity assist. A very close flyby of the planet that literally slows down its orbit in exchange for the spacecraft getting a significant boost. It's an energy exchange that's impossible to measure on the planet since it's infinitely more massive, but it does give a very significant increase to the speed of the spacecraft. This is combined with the Oberth effect, which, simply put, consists of firing the thrusters during the closest stage of the flyby, something that drastically increases the speed gained when burning fuel. This is something that space missions do constantly. Rosetta, the Comet mission, did it with Earth and Venus, and the Voyagers with Jupiter and Saturn. Although this hypothetical interstellar hunting mission would need a much bigger push from the Sun itself, it would have to pass so close to the Sun that it would be a real challenge to keep it from burning up. The problem is that going to the Sun takes time, a lot of time actually. I'm not going to go into details, but to do it, first, you need to go by Jupiter to take advantage of its gravity and get closer to the star. And to go to Jupiter first, well, I think you've got it by now. This option is very cheap, and in fact we could send several probes like this right now without any problem. The thing is that interstellar objects move so fast that we only get a few months' notice. And these missions take years, and gravity assists have to be timed down to the second. You can't improvise or change plans, so it's not really feasible. And with this, we come to the third option, the most feasible one. Parking a probe in space in one of the so-called Lagrange points so that it's ready when the opportunity arises. The Lagrange points are areas in the solar system characterized by being in gravitational equilibrium. Essentially, these are regions where the gravity of two bodies cancels each other out, allowing any object in them to remain fixed at that point without needing to spend much fuel or have an orbit that constantly moves them. A probe parked at a Lagrange point would be ready the moment an interstellar object is detected without needing to plan the mission, build the rocket, or launch it. Quickly, as soon as it received the order, it would modify its trajectory to begin a gravity assist with the nearest planet and, almost for free, gain the speed needed to reach it. The ideal would be to have several of these at the Lagrange points of Earth, Venus, and Jupiter to cover all possibilities. And this is more or less what the Comet Interceptor mission of the European Space Agency will do, which will be launched in 2029. Although it might not be necessary to reach an interstellar object to study it, because interstellar objects have already reached us. On January 8, 2014, a meteorite of presumably interstellar origin fell into the ocean northeast of Papua New Guinea. This was confirmed by the United States Space Command. However, since the data is classified, the international scientific community has not been able to verify it. The fact is that Avi Loeb, the same person who suspected that Atlas could be aliens, decided to go by boat to recover the pieces of the meteorite. They dragged huge magnets along the seafloor in the supposed impact zone of the interstellar object, finding several tiny pieces, supposedly from the meteorite, among which a curved wire fragment 8 mm long stands out, designated as ISI-2. This was mainly composed of manganite. That and platinum, materials commonly used in the manufacture of laboratory electrodes resistant to corrosion. In addition, metallic fragments composed of an S5 steel alloy were discovered, whose yield strength far exceeds that of natural iron meteorites, which matched the previous predictions about the meteorite's strength, which surprisingly was able to withstand atmospheric re-entry without disintegrating, despite moving at an enormous speed, literally at interstellar escape velocity. Was the object really interstellar? Did the fragments found come from the meteorite? Or were they human debris from nearby cities? It's complicated. There is a big debate regarding the methods used for both the chemical analyses and the calculations of the impact area, if there was one. If you want to research more about Avi Aviloev, do so with a particularly critical eye. Well, although Mr. Aviloev promotes ideas that spark a lot of curiosity and passion, and that is very important, his most recent work has been widely criticized by the international scientific community. And don't get me wrong, rebels are essential for scientific progress, but it's very hard to tell the difference between a madman and a genius. Why are so many interstellar objects entering the solar system? Are they alien technology or not? Some will tell you that human civilization is reaching such high levels of energy production that it has triggered the alarms of extraterrestrial civilizations that are watching us. That's why they've started sending probes to study us. I'll tell you that the irregularities of both Oumuamua and Atlas can be explained by physical phenomena, and that most likely this kind of object has always been passing through the solar system. But it's only in recent years that we've started to have the technology needed to detect them. Maybe before we could have detected some, but far fewer, and considering how uncommon they are, statistically speaking, it's more likely that we wouldn't have found any, which is exactly what happened. Probabilities that need to be resolved so we can reach a definitive conclusion in this video, and the only way is by exploring these bodies directly. I hope the Comet Interceptor mission is a complete success and that many more will follow. Before ending the video, I wanted to send a special thank you to the channel members who support this project and invite those of you who aren't members yet to join and enjoy these videos. If you want to support the project directly, it would be greatly appreciated if you become a member of Ciencia. Among the main benefits, you get early access to all the videos 2 days before they're published, as well as video calls with me once a month. Now that's all from me. Thank you very much for watching the video, and goodbye.